Greetings, students. Mr. Allen here. Today we're going to review infinite series. And as you know from last time, we talked about which pieces or parts of that content were going to be on this year's AP exam. As you know, they've modified that. So what I've got here is a presentation for you to hopefully go over some of those pieces. So here it comes. Oh, and the PowerPoint is on Canvas. So if you'd like to have a copy of this, I'm only giving you the copy of the blank notes. You need to fill in the notes yourself, or you can kind of follow along with this video. So remember, the idea is that you guys are doing these problems kind of before the class starts, then you can bring questions to the class. It's kind of a flipped approach. And please keep in mind that I am keeping track of who is making it to the classes. So it's just Monday. Well, it depends, like Monday and Friday one week or Wednesday the other week. Okay, so we're going to look at infinite series. And on this year's exam, it's been kind of narrowed down to these are the kind of the big topics: the geometric series, P series, alternating series, and the ratio test and Taylor series. So let's look at the geometric series first, and I've just got an example here. We've already got notes, and I'll let you look at those on your own time. So here we have a sum, infinite series, and we're asked to determine if the series converges or diverges, and if it does converge, to determine the sum if possible. So we're kind of hoping that this is going to be a geometric series, which it is. And the way you would maybe recognize that is to just maybe rewrite this as follows. So now I have, and again, this is going from n equals 0 to infinity. So we can clearly see here that A is 1 and R is 1 over E, which I should note that 1 over E is approximately 3.67, which is less than 1. So we can automatically conclude that this converges. To determine the sum, we're going to use our formula, which is A over 1 minus R. In this case, A is 1. Then we've got over 1 minus R, which is 1 over E. That's 1 over E. And this then can be further simplified into E over E minus 1, and I'll let you figure that one out. There's some steps there with getting that fraction within a fraction cleaned up a little bit. Okay, so let's move on to P series. P series, this is a P series. We're going to try to figure out if it converges or diverges. The first thing I'm going to do is I'm going to pull out that constant on the top, which is the constant 32. N equals 2 to infinity. Then we're left with 1 over n to the 1.0001. So in this particular case, this is our P series, and we have that P here is 1.0001, which is greater than 1. Therefore, this guy is going to converge as well. As long as that P value is greater than 1, this series is going to converge. And that 32 doesn't matter either. It could be basically any number. A finite number times a convergent series is still going to be a finite number. Okay, alternating series simply means that the series is alternating. Typically, it's negative to positive, but it doesn't have to always go in that order. It could go negative, positive, negative, positive, or something like that. So here we clearly have an alternating series. We're trying to determine if it converges or diverges. And so the first thing that we want to do is just identify what A sub n is. And A sub n in this case is simply 1 over n. So once we've identified that, now we've got two criteria. So this is criteria number 1. We need to show that the limit as n goes to infinity of A sub n is equal to some value, and I'm just going to call it, let's just call it L, where it's a real number. Has to be a finite amount. So in this particular case, that's going to be the limit. as n goes to infinity. I'm sorry, that is not quite correct. I said that incorrectly. I'm sorry. This limit has to go to 0. You're probably going to correct me on that. Anyways, so we're going to do the limit as n goes to infinity of 1 over n. And the limit of 1 over n as n goes to infinity is clearly 0. And so therefore it passes the first test. And by the way, it kind of makes sense. If the nth term of your sequence or series, I'm sorry, if the n term of your sequence of the series is not going to 0, then this thing's going to blow up and diverge. So this has to be 0. So that's our first criteria. The second criteria is we need to show that a sub n plus 1 is less than a sub n. Well, a sub n plus 1 would be 1 over n plus 1. We need to show that that's less than 1 over n. Well, we could cross multiply here. And then we could say that 0 is less than 1. Therefore, this guy meets both criteria and it converges. You probably already knew that from the beginning, since this was a simple alternating harmonic series, which is one that we've studied before. The ratio test. We're going to use the ratio test to determine if this series converges or diverges. So the ratio test is simply, we're going to do the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. And based on that limit, we're going to figure out if it converges or diverges. In this case, we're going to have the limit as n goes to infinity of, now I'm going to do this top term first. So I'm going to do this right here is going to be my a sub n plus 1. So I'm going to add a 1 to the n. So it's just not going to be just n, it's going to be n plus 1 squared over 2 to the n plus 1. Now I'm going to divide by a sub n, which means I'm going to multiply by its reciprocal. So we've got this limit here. And without a whole lot of effort, I'll try to pick reasonably simple ones for this lesson. We can see that the 2 to the n and the 2 to the n is going to cancel, so you'll be left with a 1/2. And then you're going to be left with n plus 1 squared over n squared. Well, n plus 1 squared is n squared plus 2n plus 1 over n squared. Clearly the 1/2 could be pulled out. And I'm just going to go ahead and jump to the conclusion here that this limit is a 1/2, which is less than 1. Therefore, it converges. If it had been equal to 1, what would the conclusion be? Well, I'll let you review that. Okay, so I think we've got one more here. We're getting close to the 10-minute mark, and I want to keep this under 10 minutes if possible. So here we're asked, and this is the final thing that we need to kind of review for the AP exam, and that is Taylor series. So here I'm trying to find the Taylor series for this function f of x with a center of 1. So this is where you have to go through and you got to find all your derivatives, etc. I'm not going to do all of them. I'll do some of these, pun intended. So it's 1 over x. The first derivative is negative 1 over x squared. The second derivative is 2 over x to the third. The third derivative is negative 6 over x to the fourth. Then you want to evaluate those functions. So f of 1 is 1. F prime of 1 is negative 1. F double prime of 1 is 2. And f triple prime of 1 is negative 6. So now we can use all of that information to say that f of x, which is equal to 1 over x, could be built up using the following. You're going to do f of 1, which is 1, plus, now we're going to do the derivative at 1, the first derivative at 1, so that's going to be negative 1. That's a negative 1. And then it's going to be x minus 1. That's x minus 1 plus. And then we're going to do the next derivative, which is going to be 2 times, let me do that parentheses. And then it's going to be x minus 1 squared plus negative 6 And then we're going to have x minus 1 to the third plus dot, dot, dot. And you can clean this up. I'm not going to do that here because it's actually hard to write this in my 10 minutes. You do not need to be able to show the radius of convergence. That is something that they have removed. So I think I'm going to end this video here. Thank you for your attention. Please get those problems done before class next time.